Hey Stats class, I'm going to go over in this video how to use your calculator just to do a basic prediction with a line. If I am looking at this and I'm deciding how am I going to make this prediction, what I'm needing to do is compare the p-value to alpha. Alright, alpha is 0.05. I got 0.000, which is less than 0.05. So p is less than alpha, so I am going to reject the null hypothesis. Now, they're not showing the null hypothesis, but what it always is for these is that there's no regression in the population. All right, and the alternate hypothesis is that the regression in the population, or the correlation in the population, is not zero, meaning it's significantly far away from zero, so there is correlation. And so the way this works is, if you have a data set, and that data set shows a linear pattern, even a slight linear pattern. So remember, R is how linear your data is. So it's a positive number, so I have a positive trend to my data, meaning it's rising. It's getting higher as I go left and right. So as I make my way to the right, my data gets higher. So if there's correlation, then our trend is described by a line that slopes. And so if I have a prediction to make, I have all these x's down here, like this is the x-axis. And I have all these x's down here. So making a prediction for that x, x1, and making a prediction for that x, x2, because there's correlation, this y coordinate is going to be higher than this y coordinate. That's the whole idea of correlation. All right, but if our data has this as the case, that there is no correlation, what that means is the data there's no predictable nature to it. It's like random. If it's going to be high, low, middle, we don't know. And so we have no predictable nature to this. So the line of best fit, when correlation is equal to zero, like the null hypothesis says, the line of best fit will be horizontal. And the height of that horizontal line is the mean of the y values. And what that means is no matter what x I pick, whether it's a big X, a small x, wherever, the best prediction is going to be just the average y value. And that's why they return this here. They're showing you the average y value, just in case you need it. So when we reject the null hypothesis, when we say that this is not true, and that this most likely is true, that means we're going to use the line to make our predictions. All right, but if we ever give the scenario where the p-value is greater than alpha, if this number was greater than 0.05, like if this had been like 0.0 or something, then that means that we don't have the evidence to support this claim, the alternate hypothesis. And so again, we're not saying that this is true. It's not suggesting the null is true. It's just suggesting the alternate is most likely not the case, which doesn't support the null hypothesis. It's just that we don't reject the null. So the null says there's no correlation, so we don't have evidence to reject that. So we proceed forth with there is no correlation. And if that's the case, then the mean of the y values is our prediction for everything. So, with that being the case, the null hypothesis is rejected here because the p-value is less than alpha. We are going to use the line to make our prediction. So the way that I do that, I'm just going to start typing the regression line, -108. So remember, this is negative. And then I add to that the slope, so plus 1.05. And now I'm going to multiply by, remember, x being right beside the number means you're multiplying, so times the number that I'm estimating with, so the 168th. And I hit enter. There is my value. It says to 2 decimal places, but I only have 1 decimal place, so that's fine just to stop there. So 68.4 kilograms is my estimation. So if, for instance, just again, hypothetical, if this had said the p-value is 0.123 or something, now that's greater than alpha. So my prediction there would have been just the y mean, 81, because the p-value was less than alpha, then we plugged into the equation.